Should the developer be focused on building the software and maintaining the software? Or do you think that security should be something that they're thinking about and considering continuously?
They should, because it's in their interests to, because ultimately they're going to have to care about it, whether they want to or not. So they'll either solve the problem earlier on and save a lot of time and effort and refactoring, or they'll be told to care about it months down the line when there's a vulnerability. And it's just easier for developers to just build it into their workflow rather than have to do it later or try and patch it by throwing something in front of it in production like a firewall, which the developer doesn't understand necessarily how that works. It's different locally, it's different in staging, it's different in production. It makes it really difficult to debug. These are all problems that developers shouldn't have to deal with. And if they do it a little bit earlier, then they probably won't.
You are listening to The Secure Developer, where we speak to industry leaders and experts about the past, present, and future of DevSecOps and AI security. We aim to help you bring developers and security together to build secure applications while moving fast and having fun. This podcast is brought to you by Snyk. Snyk's developer security platform helps developers build secure applications without slowing down. Snyk makes it easy to find and fix vulnerabilities in code, open source dependencies, containers, and infrastructure as code, all while providing actionable security insights and administration capabilities. To learn more, visit snyk.io/TSD.
Hello and welcome back, everyone, to another episode of The Secure Developer. I am very excited to be with you again today. And today I'm joined by someone that is super interesting, has a very wide background in technology, and that is David Mytton. Now, David, I believe, is a previous advisor, an active investor. My understanding is correct. You were the previous co-founder and CEO of Server Density, if I'm not mistaken. You're co-founder of Console.dev and currently the founder and CEO of Arcjet. David, welcome to the podcast.
Hi, Danny. Thanks for having me on.
That is a very impressive resume that you have in a number of different areas. Maybe we just start by having you introduce yourself and how you got into the technology space.
Hi, everyone. I started coding probably when I was 11 or 12 and started my first business in 2009, which, as you mentioned, was Server Density, which is a cloud monitoring company similar to Datadog, New Relic. The idea was that you would be able to easily install an agent onto your server and get all the stats that you needed. And at the time, there wasn't any cloud product available. Datadog hadn't started in 2009. They came a year later. And we built the product up. We sold it in 2018. At that point, it was a bootstrap business. We were 1.5 million in revenue, 25 people, growing nicely. Did a small seed round and then sold the company in 2018. I joined the Acquirer, which is an edge security platform, and helped launch their edge compute product. And then left at the end of 2019, took a bit of a break and ended up starting Console.dev as a free weekly newsletter for experienced engineers because I couldn't find anywhere online to know what tools I should check out each week. And whilst you can find interesting things on Reddit and Twitter and Hacker News, that's not what they were for. And really, there were just so many tools exploding onto the market, open source, products, services, cloud, everything. There just wasn't anywhere to know what should I spend my time on, the one or two things each week. And so decided to start the newsletter. It's just very short reviews, 300 characters of what I like and what I don't like each week. But I only include things that I think's worth your time. Did that for 4 years and just played around with dev tools all day, every day. Just been a lot of fun. Still writing the newsletter. But I also started to get into the security side of software and doing hacking challenges and learning about all the vulnerabilities that software inevitably has. And so I was thinking about, well, what's the dev tooling like for developers? And when you're writing code, there's a lot of tooling, whether it's Snyk or SamGrep or Socket for dependency analysis. There's all sorts of different things, loads of really new and interesting tools to help you write more secure code. But when you push your code into production, you end up using something like Cloudflare or Fastly or Akamai to do analysis on the network edge, which are great products, but they just aren't built for developers. They're for security engineers or network admins. They don't understand or connect to your code in any way, and they don't work with modern platforms where developers are deploying today, like Fly.io, Netlify, Vercel. And so decided to start Arcjet, which is an SDK. You install it into the dependencies in your application, and it sits at the middleware layer or on your route handlers and analyzes every request that comes into your application. You can define the rules in code, so you can change them dynamically because it's just code. And then when you take a decision, you get the full metadata back about why you made that decision. Then your app can respond dynamically depending on what recommendation we have.
That's fascinating. In fact, on the console tools, I want to put a pin in that and come back to it because I'm interested in kind of the future of where you think the industry is doing. But let's touch on the security space and Arcjet. So what problem specifically is Arcjet trying to solve that is not being solved by the existing tools today?
So there's often a label that developers get that they don't care about security. And I think actually the incentives are just different. Like, developers are there to build features or fix bugs or deal with customer requests. And security might be on that list, but it tends to be lower priority. And they'll often think that's someone else's job. And so what you end up having is that the security team force engineers to do something against their will, or the product managers force them to do something against their will because a customer has asked for some feature or you need to do SOC 2 compliance. And so the most often interaction that developers have with security is almost an adversarial relationship. And they're not thinking about security in the same way that a security engineer would. They're thinking about it in terms of a problem, like someone's abusing the API, too many requests from a particular account, or you're getting sign-up form spam, or someone's scraping your website and messing up your analytics. And so developers are thinking about this from the perspective of a problem. And a security engineer might say, okay, well, we need to buy bot detection, or we need to install a WAF, or we need to put rate limits against our API. Whereas the developer is thinking, well, how do I stop this abuse against my API? And so that's what Arcjet does. It gives you these security primitives like rate limiting and bot protection, but pre-configured in a way that a developer can just drop some code into their application and solve that problem in just a couple of minutes and get on with whatever else is coming up in their Jira tickets. But then because it's an SDK, as their use case becomes more sophisticated, as it always does over time, you can actually dig into the configuration and change things dynamically, and the product kind of evolves with your use case.
Well, I'm interested in how it works, but even before we get into how it works, David, should developers care about security? Like, should the developer be focused on building the software and maintaining the software? Or do you think that security should be something that they're thinking about and considering continuously?
I think they should, because it's in their interests to, because ultimately they're going to have to care about it, whether they want to or not. So they'll either solve the problem earlier on and save a lot of time and effort and refactoring, or they'll be told to care about it months down the line when there's a vulnerability, and maybe you've just not stayed up to date with the dependency updates, and now you've got to go through multiple breaking changes and change your code in really annoying ways. It's just easier for developers to just build it into their workflow rather than have to do it later or try and patch it by throwing something in front of it in production like a firewall, which the developer doesn't understand necessarily how that works. It's different locally, it's different in staging, it's different in production. It makes it really difficult to debug. These are all problems that developers shouldn't have to deal with. And if they do it a little bit earlier, then they probably won't.
Well, I love your answer as a 25-year veteran of the software security space. But it's funny, 25 years in, and it seems like developers are maybe less focused on security. I say that because higher level languages have taken away a lot of the things that you used to worry about. I always say, JVMs have eliminated buffer overflows, right? So some things have become a lot easier over time. And so you get developers less knowledgeable about security sometimes. But I'm glad to hear that you still believe that there needs to be a focus on it. So tell me about what Arcjet is doing, or just in general, how you think this new approach can help developers introduce security. It's an SDK, but how does it actually work? What's it doing?
So the biggest constraint that I had when I came up with the idea was in modern serverless environments, there's nowhere to install an agent. And so If you're deploying on Vercel, it's just serverless functions. Or if you're on AWS Lambda, it's just serverless functions, and there's no opportunity to pass a request through an agent. And so the typical solution has been just throw a firewall in front of the system, process all of the requests on the edge, and then if they're deemed to pass all your rules, the app then receives the request. But the app has no idea that that's happened. It just sees a request. It doesn't know that it was allowed. It doesn't know why. And then if a request is blocked, the app has no idea about it. And so whilst that works perfectly well for things like DDoS attacks, where you just don't want to see that high volume of traffic, distinguishing between a DDoS attack and just your largest customer sending you a large number of requests, so you do want to allow through into your application, starts becoming a challenge. And so being able to have this full context of the request as part of the security rules is really important. But there's nowhere to install that agent. And so the way that when I was playing around with different technologies, came across WebAssembly as a really interesting way to perform analysis using a sandboxed environment, which is perfect for analyzing arbitrary HTTP requests that you can't trust. And it gives you near native performance that works on any platform. WebAssembly is often talked about in the browser. I think Figma is probably the most famous example. It's all implemented in, I think it's C++ compiled into WebAssembly, and that enabled an amazing new approach to doing design that just wasn't possible in the browser before. But I think
maybe just for our audience, what is WebAssembly technically? I hopefully most in the audience are familiar with it, but maybe some are not.
So it's an interesting how to describe it. It's kind of like a runtime environment. It's written, everyone probably understands the idea of compiling your code into assembly so that it can be executed on the computer, on the CPU. So it's kind of a web native assembly that has a particular runtime. And the idea is you have a host that runs a guest module, but it's entirely cross-platform. So that the same code that you compile into WebAssembly will work on Linux, it'll work in a Node environment, it'll work on Windows with a Python environment. It has no underlying connection to whatever it's running on. And the way that's implemented, it gives you near native performance as if you were writing in a really low level language like C or Rust. And because of the way it's designed relatively recently in computing terms, you have to give it specific capabilities. So by default, it can do nothing, which is the perfect starting point. Mm-hmm. And then you give it specific access to things on your system. You give it APIs. And that means you've got this completely isolated environment that allows you to do things with near native speed and cross-platform capabilities, which makes it a really nice platform for deploying something into your environment for a security use case in particular.
And so why would this be more effective than your traditional intrusion detection systems, your IDSs, your WAFs, web application firewalls, intrusion prevention systems? What benefit are you getting from a WebAssembly model that you're not getting from a centralized model?
So all of those have to be installed somewhere, and that doesn't work in modern environments. So that's where we're coming from. Like, where are developers deploying today? Where are new applications? Ultimately, we want to have this working on a classic VM or a cloud environment. That's later down the line. But we wanted to start where there are no tools for developers today, which is on these modern platforms, no security tools. And so this gives us a unique capability because it's supported natively inside Node.js. And so we can bundle the WebAssembly component in our SDK. So we support JavaScript, and right now we're going to other languages in the future, but it means you can just do something like npm install Arcjet, and you've got the full API the developer can interact with, and it includes our WebAssembly module, so there's nothing else to install. It's just like another library that you would install in your application.
And who configures the rules? One of the challenges in the traditional network protection systems of various types was that you had to keep up to date with the right rules. Is this an AI type thing, or are you configuring the rules of what is allowed and not allowed through the WebAssembly?
So there's a bit of both. So the rules are defined in code. And so the developer can create the client in their code. They drop in these primitives that we have, which are rate limiting, bot detection, PII detection, attack detection, and email verification. And it just looks like another blob of JavaScript just at the top of your file, a couple of lines. You define what you want to allow, what you want to block. And then you've got this instantiated client. And so when the request comes in, you pass the request through it. It's just a single line of code, and you get back a decision object that you can then inspect in JavaScript. And because it's just code and you have the full context of the request, so you already know who's logged in, you can bring in information from the session, like what pricing plan are they on? Do they have any particular restrictions? You can change the rules dynamically. And then when we give you that decision back, you can see why we've taken a decision. So for each rule you have configured, you've got the full results. So if you know that it's your most important user, your decision is, this looks very suspicious, we should block it. You should actually say, well, I don't want to block it because it's my most important user. I'll just ask them to re-authenticate, or I'll trigger a 2FA process, or maybe you'll flag it and their account manager might reach out and say, this happened, do you know about it? It just gives you more, your application has more understanding of the security context. It can take a more customized response.
And historically, that type of action was completed by the security person. Are you finding that the developers have the awareness or sophistication to know when and how to use this type of verification? Because really, one of the key things that's happening here is you're taking the security control out of the hands of the AppSec person and giving it to the developer, if I'm understanding this correctly.
That's right, at least at the beginning. And I think for new applications, the developers understand the risk profile, but it depends on the rules. It's easy to understand, should I allow bots or not? I want to allow search engines, yes. I want to block AI crawlers and block them. Getting into the rate limiting, that becomes more complicated because different parts of your application might need different limits. And there, your security team might not know. They'll probably consult with the product team. They'll consult with the engineers. They'll come up with a rate limit configuration. But then it needs to adapt over time. And so you can start really simply by just hard coding the values. And then you could change it to a variable. So you could just read it out of a database or an internal config. You could use a feature flagging system. So you could have no rate limit. And then if you're suddenly hitting a huge amount of traffic, you could apply a limit dynamically. Or you can use this to override the rules. And so we have the ability to override the rules on the server because the SDK communicates with the Arcjet service. And whilst we never remove rules, you can modify them dynamically for each request. So that gives you kind of this staged, this tiered architecture so that you can start really easily. Developer can just run the rules locally on their laptop and test it. And you can deploy it. And then as your use case becomes more sophisticated, you can change things and integrate with the systems that you're already using.
One of the things that this is highlighting, David, is a transition that's taking place, of course, between security to developers or enabling developers to do their own security. And one of the things we talk about here at Snyk, at least, is that there's kind of three groups now that are involved in this. It's not just security. It's not just developer. There's also platform engineering or operations called different terms. Do you believe that over time, the security controls and governance are going to flow over to the developer in a more meaningful way? In other words, they're going to be the ones responsible for running these types of systems?
I think partially. I think it's not going to go as far as the DevOps philosophy went, where really developers became almost entirely responsible for running things. And then we got this specialism called site reliability engineering, who would build the platform tools to allow developers to do that. And the idea behind DevSecOps was to do something similar, but I don't think it's gone quite as far because security can be bucketed into far more specialist components because you've got IT security, you've got network security, you've got AppSec. There are different specialisms which are a lot harder to kind of break up. But I think developers are going to have more control over at least where they start in the application and then the tools that they need to use. We just haven't seen that revolution that we have in infrastructure on security in terms of the developer experience and being able to have a kind of first class integration into how developers work every day. So in their editor, there aren't as many tools once you go into production. And I think that's where we're going to start to see the differences, is developers being able to influence the runtime security and not just the, as they're writing code, security.
Well, we're clearly seeing this transition, and it's interesting. There is more power, it seems, being flowing over to the developer, but I agree, it's not as far as DevOps seemingly will take it. I guess I'm curious, and maybe this is coming back to your comment about co-founding Console.dev, as to where you see development ending up or moving towards, because clearly you're describing here a developer taking more control of the rate limiting and security type things. Do you think that the IDEs are going to change the way that software is developed? The reason I ask this is right now, about 80% of developers, I've heard at least, are using things like generative AI coding assistants. And you can see more and more of this type of evolution. Certainly the types of languages and those things are changing rapidly. I'm curious as to where you see the developer ecosystem evolving towards.
Right, and this is the creation of tools like Cursor in particular, but I suppose GitHub Copilot was the first real use case for AI with just tab complete to generate code. VS Code has had the lead for a very long time as the most popular editor, and they're now getting some very interesting competition. I think it's going in two directions. You've got just people forking the open source version of VS Code and then adding a layer on top of that. And so that's what Cursor is. It's built on the VS Code open source code base, and it's taken the ecosystem, which is probably the most important piece of lock-in in VS Code, just all the extensions and the themes, what developers are used to, and then completely change the workflow and how you're interacting with your code base. And then the other direction is to build something completely new. And something like Zed has been very interesting to see being developed from scratch, as written in Rust, and they focused on the high performance, the rendering, a much more minimalist approach, but it still has AI built in pretty natively. And so the common theme there is AI and how that's helping developers. And my personal uses, although recently I flew with Delta and they give you Wi-Fi for free, so it was less of an issue. But when I'm on the plane and I don't have access to Copilot, I'm doing some coding and I'm just waiting for it to autocomplete and it doesn't happen, or the latency is so high that it becomes painful because you're on a terrible airplane connection, that you feel it when it's not there. And it really does augment your coding ability.
So what is it that you're coding in? Are you using the former or the latter? Are you using Zed, or what do you write your code in?
I'm using VS Code. I've tried Zed. I really like it. I like their UI, but it's the ecosystem. I do my pull request reviews in VS Code. I've got various linters and formatters all set up in there, and they're just not there yet in Zed. I think that's their biggest hurdle for people wanting to move over. Unless you really want the minimalist approach, if you're used to all those extensions, it's just really hard.
Do you think we're going to get to a space where developers are no longer writing code, that it is spec driven or AI driven, or do you think, no, that's ridiculous? You're still going to have developers writing software 10 years from now?
I think they're going to be augmented. I'm not sure about 10 years. That's a very long time. So at least for the next few years, it's just the boilerplate code that is just not interesting to write. It's why you've seen an explosion in dev tools around things like, I don't want to write auth, so I'll use an open source product or a commercial product. I don't want to deal with workflows, so I'll build it on some open source queuing system. I think that's going to happen for boilerplate code, and where the innovation on the workflow is with something like Cursor, and GitHub's just added it into VS Code, is to do multi-file edits. So you want to add a property to a library and it will change the source of that library, but then it will go out and change everywhere you're using it. That's really, it doesn't require any particular skill from a developer. It's just changing it. You might have to change the documentation. You don't want to forget a particular file. That's really easy for an AI to do. But perhaps writing that library from scratch is where the developer comes in. And so I think we'll see this split. New libraries will be created by humans for novel use cases, but then perhaps the tedious maintenance of them, the general updates, the minor changes, that's where AI will come in.
Do you think that AI is going to result in more or less open source consumption? I mean, certainly in the last 15 years, we've had a huge explosion of open source. That's because developers want to code less. But with AI generating code, I'm curious what you think the impact is going to be.
There's definitely going to be more code, which is a problem in general, certainly for security. Just
Yes.
people generating it. I think the challenge is that developers probably don't read the code that gets generated, or at least they don't understand it fully without going into detail. And there can be subtle bugs or problems. I think that's where the issues are going to arise, is where there's lots of generated code, but we don't fully understand what it's doing. You can generate there are lots of online template generators. You can describe a UI you want. It'll give you the Next.js template. Those are amazing. But where I see AI falling down is when something doesn't work, and then you put in the error message and it gives you a different solution and says sorry for making a mistake, but it's still made a mistake in that, and it keeps apologizing, and you don't ever actually see the solution because it can't give you the solution because it's something that no one has seen before or is so small in its training set that it doesn't understand how to solve it. And unless you know what you're doing, you're not going to be able to fix those problems.
Yeah, one of the issues that I see right now with the code generators is it's dragging you down to the mean, I'll say. If you're a senior developer with 10 years of experience, it's being trained off all the open source permissive code, which might be not as good. And as you say, the secondary problem is that it hasn't seen a novel solution to an existing problem. There was a study done last year, and 36% of the code generated, this was by Copilot, introduced a vulnerability, and everyone says, well, that's horrible. And I say, well, no, that's just the average because that's what's being generated over time. What do you think it does to languages? Because we participated in a study with MIT that's about to come out, and it was on frameworks and packagers and all of that. But one of the things is we saw a huge explosion in emerging languages like Rust. Do you think we'll continue to see that? What do you think are the interesting languages and frameworks that will continue to emerge?
Rust is one of the most popular languages in terms of developers want to be able to write in it, but it's very difficult still to find developers with production experience. I found this when trying to hire the initial team for Arcjet. Every developer you speak to wants to write in Rust, but it's just there are very few who have enough experience to, certainly an early stage startup, to just jump in and get going straight away. And it's just because not many people are running it in production, and there's not as much kind of built up experience there. We chose Rust because it doesn't have a garbage collector. And whilst my background is writing Go, when we were compiling to WebAssembly, it would have bundled the Go runtime and the Go garbage collection into WebAssembly, which would have increased the bundle size. And also, we don't want to have another garbage collector running in your environment. So it's very much a practical choice. And for writing WebAssembly, Rust is the most advanced ecosystem with the most tooling for WebAssembly. I think we'll see lots of interesting other languages appearing. Elixir gets a lot of talk at the moment, particularly with Phoenix, as almost like a Ruby on Rails type replacement where you can build the full stack of your application. The front end can be dynamic, it can be distributed, and it's all built into the whole system. So rather than having to kind of mix and match different systems and try and hook them up, you've got this entire ecosystem that's designed specifically for this use case. And something like Gleam, which compiles into the Beam VM, is a really interesting. It's not fair to call it an experimental language. I think it's experimental in the sense that it's kind of created by one person, and there's now an ecosystem, but it's not. There aren't as many examples of people using it in production, but it's a really nice language to work with, and doesn't have the intimidation factor that Rust has.
Yeah, well, we certainly see the booming projects are all Java, JavaScript, Golang, Rust. Still plenty of C and C++ and more legacy languages out there. In fact, we get asked for COBOL all the time. We see the full gamut, but they're not the growth areas for sure. Do you think that LLMs will change the dynamic at all? You mentioned difficulty in finding Rust developers, and we have difficulty finding kind of those senior developers on the cutting edge languages. But I'm also finding a lot of difficulty in finding AI developers or people with experience in working with LLMs. Do you think that's going to change the dynamics at all?
I think it's going to have an impact on different sides. So vendors, for instance, are going to have to design their documentation, not just for humans, but also for the LLMs to consume. And this becomes a real problem if you're a developer trying to use a company's product and doesn't understand it or has the wrong documentation or an out-of-date documentation. So I think we're going to see kind of specialisms around writing docs for LLMs to consume and teaching them how to do things. And then in terms of just understanding how LLMs work, I think that's going to be important for debugging why certain things are happening. I think at the moment we're used to ChatGPT. Basically, that's the only one that matters, although there obviously are other models. That's the one that most people are using. We're used to these models as just a single thing, but as they get deployed into production tied into different applications, all types of different models are going to be there because it doesn't make sense to pay OpenAI huge amounts of money for their most advanced model. And so you're going to get all these different types of models that are built into applications that get used at the right point, depending on cost and how advanced they are and the speed that you want to return a response. And that's going to make debugging applications particularly challenging, knowing which LLM was triggered and how it came to a decision, what results it gave to the user. That's going to be a real challenge.
Yeah, I see multimodal systems for a long time to come. And partly because, as you say, it's cost, but other times some of the models are tuned for specific things. So, for example, when we wanted to generate AI fixes for code issues, we found StarCoder to be so much better than GPT-4. And so you'll find things that are tuned for one thing versus another. And it's going to be the new software bill of materials. We're going to have an LLM bill of materials. You're going to have to declare all the LLMs that were used and track the integrity of them and the data going into them. It's definitely an interesting area for sure.
Yeah, absolutely.
Well, David, it was a great conversation, kind of spanning the security spectrum and what developers are doing for security and where development is going. I guess I'd just like to end on what makes you most optimistic for the future. If you look out 5 years, what do you think is the most interesting area of the software development space, areas that all of our audience should be thinking about and looking into?
So one thing that I didn't mention in between starting my company and starting Console is I did a master's degree in environmental technology and then specialized in energy science. And I've been doing a part-time PhD at Oxford in sustainable computing. And whilst it's perhaps not related to thanks, it's not entirely related to security, but I think on the optimism side of things, the progress that the cloud industry and then tech in general is making towards clean energy is certainly one to watch because there's way more interest in it now than when I started a few years ago. It's not just the big tech companies, but the W3 group, working group just announced a sustainability group. There's lots of work happening in how your phone and your operating system understand the energy consumption and the carbon intensity of the grid. And I think software engineers are thinking a bit more about not just how much energy their infrastructure costs, but also what the carbon impact of that is. And I think that's a really positive direction. Despite all the gloom about climate change, I think on the energy side of things, the energy transition, that is trending in a very good direction.
Well, that takes us almost full circle because WebAssembly gives you the ability to distribute out and use computing out at the edge that is already there and is wasted if you're not giving it instruction sets to run. So I love that it brings us back to the very beginning of the podcast. Well, David, it's been a pleasure having you on. Thank you. And if people want to reach you, where would they reach you? What's the best way to contact yourself?
So I'm on Twitter and also just joined Blue Sky. So I'm on there, also on LinkedIn and email, classic email still works, david@arcjet.com if you want to reach out.
Awesome. Well, thank you for joining, David, and thank you to our audience for joining another episode of The Secure Developer. We'll see you next time.
Thanks.
Thanks for tuning in to The Secure Developer, brought to you by Sneak. We hope this episode gave you new insights and strategies to help you champion security in your organization. If you like these conversations, please leave us a review on iTunes, Spotify, or wherever you get your podcasts, and share the episode with fellow security leaders who might benefit from our discussions. We'd love to hear your recommendations for future guests, topics, or any feedback you might have to help us get better. Please contact us by connecting with us on LinkedIn under our Snyk account or by emailing us at thesecuredev@snyk.io. That's it for now. I hope you join us for the next one.